Hacking that move. And it's here, right? Yeah, because such goes up.
All right, let's get started. We worked on dilations yesterday. We'll finish that up a little bit in the indirect measurement, which we have to make sure we understand what we're talking about here. So, we're talking about, or learning about indirect measure. We started yesterday with all, okay. All right. You're going to have some type of transformation. It can be reduction or enlargement. All right. So when we're talking about this, we started yesterday. We're talking about the measure from, we said bridges, things like that, and that's what it's going to be. The overpass at Atwood, those guys could actually get out there and measure. But what did they have to do? They had to build up the ground so they could actually have an overpass, right? So you have engineers that have to calculate all this. So we have to get a measurement for that. Trying to think where we have something that we see. Over at Sterling, if you go the back way towards NJC, they have the overpass and they have the regular highway that, I don't know what road that is. Comes from Haxton or Holyoke, I don't know what it is. Anyway, might be 14. Anyway, it goes underneath the overpass, right? So again, we don't have the interstate, 4 lanes of traffic at 80 miles an hour, and then we have to stop and cross. So that's what we're trying to do here. So what you guys have to do is you guys are going to have corresponding sides. You guys are going to have similar, and then we're going to have a scale factor of enlargement or reduction. Now, for our purposes, probably going to be enlargement the majority of the time. If we're building a bridge, we're going to have a little model, or we're going to use dimensions off somewhere else, and then we're going to build a bridge. Obviously, it'd be an enlargement. Where we might have a reduction in size?
A bridge.
If we had the bridge to the model, that would be a reduction. But the model to the bridge, we didn't have a model for the school, but we had blueprints. So it's a similar function. 1 inch was equal to 10 feet or whatever they had. And then we took a look at, my room, Mrs. Randall's room, whatever, that's what you got. So what you have to understand is sometimes it's impossible to make the dimensions work because we're not there. We can't see it. We can't do it. Generally, water's the key. That Swanson Lake thing, they got a dam. I can't even imagine how long that thing is.
It's about a mile.
I would say at least a mile. So a mile, and obviously some engineer did exactly this. You guys understand that? They did exactly that. Yeah, no. Oh yeah, we can ride in a boat. Well, I didn't know any tape measures ran a mile. Maybe they do, or you just go 10 feet, mark it, or you mark it with. You see what I'm saying? So that would be the prime example of what we're trying to do. And it, come into an engineering aspect or something along that line. So we're going to look at a couple of their problems. Make sure you understand, and make sure they do the one problem. Yeah, they do that in a second. Oh, they do it first. Okay. The problem that they always use is a person and a flagpole. I mean, not always. They sometimes use a ladder. Okay, we have a flagpole, and we have a person. Yeah, there we go. So artistic I am. Nice is right.
You draw about like terriers, like
yeah, looks right here. Some girl at
The broken leg.
Okay. Anyway, what we're talking about is they'll talk about a shadow. Okay, and this is a perfect example to use that for. If we have the flagpole in the middle of the afternoon, 2 or 3 o'clock, the sun is almost directly south of the flagpole. So we get a shadow. So if we have the flagpole and our flagpole is, we'll say it's 30 foot high, it's probably 20 foot. 20 foot high, and we get a shadow that is 10 feet. All right? We got a 20-foot flagpole, the sun's shining on it, we got a 10-foot shadow. Okay? We've got couch over here. We've got to make it a little smaller. Okay? So we have a couch. Couch is 3 foot tall. Okay? And we need to find out how long couch's shadow is. You guys understand that? That's what we're doing. I mean, that's all we're doing. Do you understand that? I mean, we can go out there today. We can find out what our diagonal is. We can find out what the shadow is. We can find out how tall the flagpole is. Things of that nature. We cannot measure this. We can measure the shadow, but we cannot measure that. So this is what we would get. So we have, and again, you guys have, he said it yesterday. I went small to large every time. Okay? Perfectly fine if you're answering the question or you recognize what is being asked, and then the answer you get, we have to have the reciprocal of that answer. So in this instance, you want to do small to large again? Let's just do small to large. Everybody good with that?
Yeah.
It is a ratio, so we just set up our ratio. So over here, small to large, and we're going to go 3 to 20. Those are corresponding. And then we're going to go equals x to 10. If you cross multiply, we'll be able to find out how long the shadow is for Tara. Does that make sense to everyone?
Yeah.
They have to give you 3 parts out of 4. You know, if I make this a decent number, instead of trying to traumatize
4
cows.
foot 11
No,
and
it's
a half.
4.
Just 4?
4
We're
foot.
not 5.
No, it's 4 foot 11 and a half.
I'm not putting that. Use
That's
5
not bad.
today then.
Yeah, that's
You guys understand that? So immediately you guys will see that and you'll say, hey, we're 4 times as big over here, right? So that means we're 4 times as small here? Or does that mean we're 1/4 the size? 1/4 of the size. If we're 4 times bigger over here, we're 1/4 the size here. You don't have to go through this, although we will. We have equality, so we get 20x is equal to 50. Therefore, x is going to be 50. 5 divided by 2. X is going to be 2.5. The shadow is 2.5 feet.
Oh, okay, I got it.
You guys see that?
Yeah.
Now, this is small to large. There's nothing wrong with that. I personally just do left to right or first to second, whatever they give.
So it's fine, we do that.
So, yes, it's fine. So I would have done, in this instance, large to small, I would have just got 20 to 5 is the same thing as 10 to x. When we do all of this, we get the same answer. Now, does everybody follow that? So what that says is the flagpole is 4 times as large, and the shadow has to be 4 times as large as well. Or we say Taryn is 1/4 the size of the flagpole, therefore his shadow should be 1/4 the shadow of the flagpole. And you guys, does that make sense to everyone? Is there a question about it at all?
What if you did flagpole height
Okay,
divided by the shadow?
nope, that's fine. Okay, the thing about it is, what you guys have to determine is what is given. The givens are the facts of the problem that the book has used. So in this case, you want to go 20 to 10, right? So he wants to go flagpole to shadow, correct? So we got 20 to 10. Is everybody comfortable with that? Makes sense to everyone. Okay, then we just have to be corresponding over here. We're going to go 5 to x. Everybody see that?
Yep.
What do we get? Still get the same problem. And the issue, if you do things like this, the issue is you're not using corresponding sides to match up. If you don't have corresponding sides matching up, then you have an issue. I mean, he went he went flagpole to shadow. As long as you go flagpole to shadow, you're going to be fine. Now, the issue becomes this. Somebody's going to do this. And we're going to get 10x equals 100. So x is going to be 10. So what we're going to say is Karen's shadow is the same as flagpole. If you use common sense, that makes no sense whatsoever. And what happens is when you guys write a proportion, in other words, a comparison equal to another comparison, it will always be true. You understand what I'm saying? Your work, as long as you do not miscalculate, you're going to get the correct answer to your problem. If you do not set up the correct problem, obviously your answer is not going to work. And so what did we do in all 3 problems? We had corresponding to corresponding, regardless of how we set it up. I do not do this. And the reason I do not do that is because kids make this mistake. That's all. I mean, it's perfectly fine. It's a very good way to do it, but you have to understand as a student what is corresponding, and you can't get careless. That's all. And the other thing is this, we were 20 to 5. Well, if that's factual, then we know that the flagpole is 4 times the size of Taryn. We know that the shadow must be 4 times the size of the other shadow. Couldn't we just have taken 10 divided by 4 and gotten 2.5? Now, that would be your way. Do you guys understand that? And those ways are good.
What if you just did like you saw that the shadow on the flagpole was half of the actual flagpole,
Perfectly good.
and then you
Sure.
saw couch was 5 foot.
That would be 2.5. You guys hear what he said? He says, hey, we were exactly half. If you guys see those things, which some of you think that way, I mean, several of you do it that way. If you think like that, it's perfectly fine. The issue becomes this. Wait, bad numbers. I mean, if we got good numbers, there are always shortcuts we might be able to utilize. If there are shortcuts to utilize, by all means, do that. All right? Now, does this make sense? We can't go measure the flagpole. All right? So the question, or a question, would be along this line. We've got a person, so we use couch again. We've got the height to the shadow, 5, and then we're going to say the shadow is 12. Okay? So the sun must be low, right? You guys see that? So now we have the flagpole, and we want the height of the flagpole. That's what we want. Okay? So they got to give us something. If we're trying to find the height of the flagpole, then the corresponding thing that we're going to get is the shadow. We have to have an unknown. The unknown is what we're trying to solve for. So if we've got that, then this is the height of the Taryn. This is the shadow of Taryn. We want to make that equal to the height of the flagpole and the shadow of the flagpole. So they have to give us something. They're asking us to find the shadow of the flagpole, which would be something we could actually go measure. So more than likely it would be the height of the flagpole. So if we're going to say the shadow, and we'll just say it's 36 to make life better for ourselves. Okay? So our problem now becomes doing it Anderson's way, comparing the object to itself, we're going to go 5 to 12 is equal to, now what does 36 represent? You have to know what it represents. The book will tell you. You have to read and you have to comprehend. In this case, they said the shadow was 36. So how tall is the flagpole? That has to be the question. Multiply by 3. Well, we multiply by 3. Is that a shortcut? If it works, why wouldn't you use it? Does that make sense? If it works, why not? Because all you're doing is taking a fraction and getting an equivalent fraction. If I multiply by 3, I get equivalency. What do you have to do in a fraction if you're trying to get equivalency? Numerator times your rate of change and denominator. All right? Let's just say it was 30. If it's 30, maybe we don't want to do that because that turns into a fraction. Again, perfectly fine. Cross multiply. 12 times TF, if you will. And equals 150. Good. We divide by 12, get the height of the flagpole. Divide by 12, get a number there. Height of the flagpole. So we get 1, what is that, 30? 12 and a half. Okay? Do you guys understand? And they use flagpoles and people, or they use ladders. Okay? Same thing, same effect. All right, does that all make sense to you? And really the key to all of this is correspondence. If you get the right correspondence, you're going to be fine.
Basketball hoops.
Yeah. Whatever. All right, take a look at the second example. That's a little lake thing. We need to go through that and do that. All right, the key is someone has done this. All right, not us, someone else. So when they give this to us, someone's trying to build a bridge or find out how far the water is, whatever the case may be, but they have to give us, and they're forming a triangle. A triangle is easy to get corresponding parts, right? So they have triangle, what do they have? Triangle what? Just give me the letters. What?
QVU.
TU.
QVU. And SCU.
Just a second. Similar? Yes? Is that what it says?
Yeah, exactly.
You guys understand that it's similar? So we're going to have corresponding? Okay. Triangle what?
STU.
SQU?
STG.
STU? Okay. All right. The thing that you know that QU goes with ST. You don't have to draw it. Carl, are you listening? This part where you don't have to draw. Makes your life better. You guys understand that QU is the same as ST? Does anybody not understand that? Our book does it correctly. They write it correctly. This is corresponding to this to that to that. All right? Does that make sense? Does everybody understand that? So they have to give us dimensions, yes? Okay. Now, are we going small to large? Probably. Model to the real thing? Okay, so let's go small to large. What are they giving us? They have to give us something.
16.
16?
Yeah.
For the small?
Or no, that's for the large. 10 is small and 16 is large.
Yeah. Okay, those are corresponding. Does everybody see that? There are 6 parts here. Okay? The question will be, what is given, and then we have to determine what is being asked. This is a given. Does everybody agree with that? Okay. What are they asking us to find now? One of the sides of something. Is it the large?
It's the
Okay,
large
so what is
20
the
X.
other part?
20 over X.
20 over X.
20 over x? Okay, so we're not gonna have an issue here, right? So that's gonna be 32. Does everybody follow the shortcut? Now you guys will see this. You know, kind of wish they wouldn't do that because you think they all work. Some of them work. The book wants some of them to work. However, if it was 15 or 35, then we would have to do some other work. Does everybody understand that? We're right here. Right here. 16 times 20 is 320. 32 times 10 is 320. This is true. That is the measure for X. Is there a question here? Confident in what we're trying to do?
Yes.
Okay, good. What's the other one they give us? So hopefully it's not.
QRS.
We have QRS?
Yeah.
So a different problem?
Yeah, QRS, you want to.
QRS,
And URT.
similar to,
Who's your RP? Closer.
yes? Is that right? Okay, so once again, what you guys have to recognize when you do the problem is Q and R are the same as U and R. R and S is the same as R and T. T and U is the same as S and Q. And again, they might have two questions on the actual sides, but they have to give us at least one. Otherwise, we can't do it. I mean, anytime you set up a problem like this, QR, we'll just say over RS, this would be comparing the same triangle. You guys understand that? Would equal UR over RT. Good? I'm just showing you, I'm comparing it the way you ask, and I'm not using numbers, I'm using measures. So if I have QR, this side, is it corresponding with this? That's all. Yes or not? Yeah, well, I was just doing it your way. Well, you said you said can you compare the flag and height, the size of the flagpole and the height? Did you not? Oh, you were just asking.
Well, no, listen, I was kind of meaning like Tyler, right, where you have either, if you're doing small to large,
Yes.
it would be 2, and if you're doing large to small, it's half.
This right here is true. We probably, or I would, do this. This side, this length, this edge, equal to that. Okay? And then I would compare, say, RS to RT. All of these things are the same thing. These two things go together, put them together here, corresponding parts are over here. All right? The key is corresponding parts. If you make a mistake on that, like I said before, you will get a correct answer to your problem. It's just not the right problem. Right? That all makes sense to us. And we understand why you do this. We can't go out to McConaughey if they want to put a bridge so traffic flows better. You can't go out to McConaughey and do a bridge and just get out there in the water and try to build a bridge. Okay, San Francisco Golden Gate Bridge?
Yeah.
What do you guys think? They just went out there and measured it? No.
Looks like a pole into the ground between out there.
Oh, you see that bridge? You see all the pulleys they have? The bridge was built in the 1920s, 100 years ago. And it's still standing. When they had the earthquake and stuff like that, it wasn't damaged like some other thing.
One way you can measure now going over water is fish diving.
Okay.
Yeah, but that used
Chuck boots
Yeah,
in the water.
Okay, are we good here?
Yeah.
All right, this is what we're going to do. We have All right.
Sure.
We have 1, 2. Okay, let's go 1 through 10 and test prep word find. We don't have a lot of problems with this. There's a lot of reading. If you do not read and comprehend, you cannot set it up. You got to take a moment to read it and comprehend. I would set it up the way we are doing our problems. Not everybody wants to do it exactly the same, and that's perfectly fine. But we have to have corresponding parts, and then you'll all be good. All right, and it's important to learn. Monday, we'll probably do the review, and we have to do the review. So if you guys beat Centric by more than 20, okay, you will pick a lesson, and you will not have homework. It's not going to be Monday. It's not going to be Tuesday. Say it might be Wednesday or Thursday of next week.
What about this?
What about this?
We do that 1 extra credit point on the test. 1 free extra credit.
A point? A point doesn't help you.
And
One
it helps
point
you
does
have
not
to
help
do
you.
anything.
Hey,
Hey,
300%
we-
on a test.
Now, you can't beat them by 50.
Oh,
Mike, go there,
Oh,
okay,
Oh,
and then,
that's a challenge. Let's go.
and then laugh about it as you.
As I get 100% in this class,